How's it going, all you kids out there? This video I'm going to be talking about 1.7. 1.7 is dealing all with inverse functions. And here are the truths. Oh, Hank, you hit my paper.
I'm sorry, let me fix it. Ooh.
Introducing Hank the dog.
Yay!
Hank's going to help me teach today. Or not, he just left the room. Bye, Hank. Okay, so these are some truths about... Oh, no, now everything's all messed up. Let me fix this. Hang on. Much better. Thank you for the assistance, Hank.
You're welcome.
You're funny. Okay, so with this, some of these are things you learned in Algebra 1. If not, no big deal. We are going to learn them right now. In order to find an inverse function, you switch in the x, y values in exactly where they are in the function, and you solve for y to figure out what the inverse is. The notation is represented as f inverse of x, f to the -1 of x, kind of ish. It just means f inverse of x. They reflect over the y equals x line. So if you have y equals x, this, the reflection of that would be something like that. So those two functions would be inverses of each other. If you take the composition both ways, they will both come out and simplify as x. This is going to be our algebraic test. Algebraic test. Horizontal line test determines if the inverse is a function. So with the horizontal line test, real quick, if we have a graph and we go like this, if we draw a horizontal line anywhere throughout my function, and it only hits one point, just like the vertical line test, but it's horizontal, that means the inverse is a function. If I have a function like our parabola, and I run a horizontal line, it hits more than one point, all that means is if I reflect this over the line y equals x, it would look something like this, and my vertical line test would fail, so the inverse function would not be a function. Horizontal line test determines if the inverse is a function. In the case of y equals x squared, it is not.
Yeah. Oh yeah.
Oh no!
Oh yeah.
Alright, in these first sets of problems, we're just going to be determining if the function exists, so I'm going to be using my horizontal line test. So, when you graph your reciprocal function, you have a graph something like that, and like that. And if you pass a horizontal line test all the way through, you're good. Kind of gets a little sketchy towards 0, but don't forget these points are getting closer and closer and closer to 0, but they are never touching it. And again, these ones are also getting closer and closer to 0, but never touching it. So that will actually still pass your horizontal line test. So since it passes our horizontal line test everywhere, the inverse function exists. Yes. With this one, when you graph it in your graphing calculator, you will find that it looks something like this. Okay. On this one, if I put a horizontal line test, it hits once, twice, and a lot of different places. Okay, so since it hits more than twice in any place at all, really, no inverse function exists. Yay. Alright, looking at our next example, find the inverse if it exists. So first you want to check it if it even exists. When you graph this one in your calculator, this is your cubic function, and it's just moved down 16, so you'll have something like that. You can run a horizontal line test throughout that entire thing, and it works. So now we can actually find the inverse. Don't forget we find the inverse by switching the x and y values and then solving. So since this really stands for our kind of y value, I'm going to make that now my x value, minus 16 plus y cubed. And then it's just a matter of solving for y. So I will add the 16 to the other side, so plus 16 plus 16. So I have x plus 16 equals y cubed. To get rid of that cubed term, I can take the cube root of both sides entirely, so that I have y equals the cube root of x plus 16. And then just change this right back to the inverse notation. So f inverse of x equals the cube root of x plus 16. And there it is, all pretty and nice. I can even draw a little bow and make it look even prettier. Oh, it's so pretty. Alright, doing the same sort of deal with this problem. Find the inverse function if it exists. So when we graph this, Let's see, I should have done this. Hang on, 1 minute.
Haha, but I'm magic and it only took 1 second.
So if we look at this, again, we always want to check the graph first. Check out the graph. The horizontal line test will not pass. It fails multiple times. So since the horizontal line test fails, I don't have to do any more work, and I would say no inverse function. Cool. Alright, in this example we are going to verify that functions are inverses of each other. Remember, this is back to our algebraic tests. If f of f inverse of x is equal to f inverse of f of x, and they are both equal to x, then this is their inverse functions of each other. Okie dokie. What we can do is this is saying that this is maybe the inverse of this function, so I'm going to treat that like it's f inverse of x. So all I'm going to do is the composition of functions, f of g of x, and hopefully that will simplify to x. So I know g of x is 6 minus x over 3, so this is f of 6 minus x over 3. Then I'm going to take this, substitute it in for x, just like we did in the last video. So 18 minus 3 times 6 minus x over 3. And then it's just a matter of distributing everything to everything and hoping that this comes out with only x. So I'm going to distribute the negative 3 to both of these terms. If I distribute it to the 6, this is 18 minus 18. Negative 3 times negative x over 3 will end up just plus x. Well, 18 minus 18 I'm pretty sure is 0, so I'm left with x. So it is good on that side. Now I have to check it the other way around. I have to say g of f of x, and hopefully this will also simplify to be just x. So g of 18 minus 3x, I will take this, substitute it in where I see x in this function. So I have 6 minus 18 minus 3x over 3. Well, I can factor out a 3 from both of these such that I have 6 minus 3 times 6 minus x all over 3. 3 divided by 3 makes 1. So this is really 6 minus x. Distribute the negative. So I have 6 minus 6 plus x. 6 minus 6 makes 0, so again, this simplifies to x on that side. Since it simplified to x when I did f of g of x and g of f of x, I did it in both directions. You have to do it in both directions. It doesn't always work, but we need to see that it works in both directions in order to prove that these are inverse functions of each other. That is the work that we would want to see. Once you have solved that it has come down to x, you are good to go. Alright, looking at another example. Verify the functions are inverses of each other. We have the function f of x equals x squared plus 10 as long as x is greater than 0. So don't forget, as long as x is greater than 0, that graph just looks like that because we have it when the domain is bigger than 0. And then g of x is the square root of x minus 10, so that would be something along those lines. Next, it just moved down 10, it's a square root function. Oh, no it's not! It moved to the right 10. I apologize. Move to the right 10. Ah! What's wrong with you, Mr. Pike, you cray-cray? Okay, so in order to verify again, we have to do f of g of x and g of f of x. Prove it both ways that it simplifies to x. So f of g of x function is square root x minus 10, so f of square root x minus 10. Then I'm going to take square root of x minus 10, plug it into my f of x equation. So I have square root x minus 10 squared, because that's x squared, that's our new x, so square it, plus 10. Well, this will just simplify to x minus 10 plus 10. Negative 10 plus 10, I'm pretty sure, is 0, so that simplifies to x. On your right-hand side, g of f of x, well, f of x is x squared plus 10, so g of x squared plus 10. Substitute this into this equation, so I have the square root of x squared plus 10 minus 10. Well, nothing to distribute there, so 10 minus 10 is 0, and then I have the square root of x squared, which again is just x. So it simplifies to x in both directions, and there we are. Happy day, sad day, glad. Oh, I messed it up. Whoops. Happy day, sad day, get some trash bags and make it a glad day. Alright, in this problem, we are not given an equation or anything like that. We could come up one if we wanted to, but I'm not going to worry about that because it is just asking us to graph the inverse function. And we know that the inverse function is just a function that is reflected over the line y equals x. So it's just your parent linear function. So it is going to reflect over that line. So it will look like the same thing, just on the exact opposite side. So since this is kind of one away there, it is kind of one away there, this is 3, so this will be 3. And then I can just draw a straight line, draw a straight line, and they reflect over this line. Everything that was down here reflects across the line there, same vice versa, and everything that was down here reflected across the line and is now on the same direction that on that side of the line. So it's kind of like a reflection over an axis. That's a reflection kind of over the y-axis. But you can fold it on that line and it will map onto its inverse function. Cool. Yay. Yay. Sideways. Yay. Ah, it even looks like he's closing his eyes. He's so happy. Apparently there's a guide on the internet of how to wash a rabid monkey. Huh. Alright, here's the last example that we are going to look at. Yay! Oh no. I messed up my monkey for the first time in forever. That's supposed to be a leg. Yay, he's kicking a ball. Yay, playing kickball. Kickball. Yay, he kicked the ball and he's holding a banana. I'm sad. Anyways, graphing the inverse function. Again, we are going to reflect over the line y equals x. So it will look like the same thing, just the opposite side. If it helps you, you can turn your paper sideways. And you can see in order to reflect this, you're just going to flip it to the other side. So, same deal, just opposite side of the line. So that it makes a mirror image. And there would be your reflection. Hopefully this video, guys, has helped you guys out. As always, I will be in C101 as long as I am in that room and they don't fire me for putting instructions of a rabid monkey online. Anyways, I'm going to stop talking about that so I don't get fired. So, I hope you guys have a great day. Whatever you're doing, have fun, and then enjoy me. Enjoy talking to me. I don't know. I really have no idea what I'm saying. I hope you guys understand this. If you have questions, go to one of your teachers. Come to me. I promise I'll help you. We love you guys. See you in class. Bye-bye!